Our 5.1 lesson, we are looking at simplifying expressions with powers. And again, all our expressions in this case are going to be monomials. So we're looking at simplifying each monomial with a power. Our first monomial here is b to the second, and that's being taken to the fourth. B to the second we recognize is just b times b, and that's being taken to the fourth power. So longhand way, we would write that as b times b, because here is b squared to the first power, b times b to the second power, times another b times b, this is our third power, times b times b. That's our fourth power. So we have b squared to the fourth power. So 1, 2, 3, 4 of our b squareds. Now when we look at that, we notice that we have 8 b's together, so that is b to the 8th power. And that is our final answer. Now again, that's if we do it longhand way. We want to move away from doing everything in longhand. We want to learn the different properties of them. So we need to look at different properties. This one is called the exponent to exponent property, which means that we multiply our exponents. Before we were looking at things like x squared or x cubed times x squared. So that would be exponent times an exponent. In that case, what did we do? We just added. So that would be x to the 3 plus 2, which is the same as x to the 5th power. So exponent times exponent means add. Exponent to an exponent means multiply. So it means on this one, our b to the second power being taken to the fourth power means b to the 2 times 4, which means that it is b to the 8th, which was the same answer we found longhand, but just done in a much cleaner fashion. So if we apply that same principle to our next one, we have a monomial of negative 3c squared d to the 5th power being taken to the 3rd power overall. When we apply our exponent to exponent, we need to do it with each individual piece. So our constant is negative 3, and that's implied that negative 3 is to the 1st power. And we kind of notice that that is being taken to the 3rd power. Since we have already that it's negative 3 to the 1st power, we can just leave it as negative 3. We also have our first variable of c already being c squared, but we are taking it to the 3rd power. And we have our variable of d to the 5th power, again still being taken to the 3rd power. So each of our pieces, our constant, our c variable, which is c squared, and our d variable, which is d to the 5th, each are going to our outside power here, which is 3. So we need to apply our exponent properties to each of those. We know that negative 3 to the 3rd power is going to be negative 27. Our c squared to the 3rd power is c to the 2 times 3. And our d to the 5th to the 3rd power is going to be d to the 5 times 3. We're not quite finished yet. We need to simplify this some more, so it's going to be negative 27. 2 times 3 is going to be 6, so c to the 6th. Similarly, d to the 5 times 3 is 15. So in the end, our final answer is going to be negative 27, c to the 6th, d to the 15th. Moving on. In this instance, we see that our monomial is a fraction, which is okay because fraction just means division. So as long as it's not addition or subtraction, we're still using just division, multiplication, which means it's a monomial. So we have our monomial to the 5th power. Anytime we have a fractional monomial to a power, we need to do the power to each the numerator and to the denominator. So here we have negative 2a as our numerator to the 5th power, and b squared, our denominator, to the 5th power. From there, we just apply it to each piece. So negative 2 to the 5th power, a to the 5th power, that's our numerator. B squared to the 5th power, it would be b to the 2 times 5. Simplifying even more, we know that negative 2 to the 5th power is going to be negative 32, and a to the 5th power is a to the 5, and b to the 2 times 5 is b to the 10th. So in the end, our answer is going to be negative 32, a to the 5th, b to the 10th. On this last one, we recognize that we have a negative in our exponent that our fractional monomial is being taken to. Now, anytime you see a negative, that means take the reciprocal of your monomial. So the first thing that we do is reset the monomial to the reciprocal. So it would be 3 over x, and maintain the value there, which was 4. So our negative meant the reciprocal, and we're keeping it to the 4. Now from here, we know what to do. We know that it would be our numerator to the power over our denominator to the power. And simplifying that down, we know that 3 to the 4th power is 81. X to the 4th power is x to the 4. So that would be our final answer. Moving on from here, we have simplifying expressions using several different properties. There's a lot going on in this one, so there are a couple different ways we can go about it. First off, we can recognize that it is a monomial to, or a fractional monomial to a power. So the first thing we do is separate out the numerator and denominator. So our numerator is negative 3a to the 5y being taken to the 5th power, and our denominator is a to the 6y b to the 4th being taken to the 5th power. Now from here, we recognize our numerator needs to be broken up into our constant. So we have negative 3 to the 5th power, and our variable of a, which then becomes a to the 5y to the 5th power. So that is our numerator. Our denominator also has an a value. So we'll use our a to the 6y being taken to the 5th power. And it has a b value, or a b variable there. So we have b to the 4th being taken to the 5th power. Again, we're not fully done. We need to simplify these down. Negative 3 to the 5th power is going to be a negative 243. And a to the 5y to the 5th power is a to the 5y times 5. Similarly, a to the 6y to the 5th power, be 6y times 5. And b to the 4th power to the 5th power would be b to the 4 times 5. We got one more step to simplify it. It would become negative 243 a to the 25y, because 5y times 5 times 5 is 25. Same thing down here, we have a to the 30y and b to the 20th. Now we're not quite done here either, because we notice our similar bases. We have an a base in both our numerator and our denominator. So we need to subtract out 25y from both of these. That leaves us with an a to the 0 here, which just becomes 1, so we can get rid of it. And if we take away 25y on this side, or in the denominator, we are left with 5y. 30y minus 25 is 5y. So our simplified answer, we'll write that down here, is going to be negative 243 alone for the numerator, and our denominator would be a to the 5y, b to the 20th. Oops, that's the base. That would be one way to solve it. Now in that situation, the method we did was to apply the properties first and then simplify it. What we could do instead is simplify it first and then apply our properties. Because we notice that we have our a and a in both the numerator and denominator. So we can simplify first, crossing out the 5y, or taking away 5y, should I say, leaving us with a to the 0, or 1. And taking away 5y here leaves this just as a to the 1y, or a to the y. So our monomial now becomes negative 3 over a to the y, b to the fourth, to the fifth power. So we apply our properties. We know that the numerator, negative 3 to the fifth power, and our denominator, a to the y times b to the fourth, that to the fifth power. Simplifying down, negative 3 to the fifth power is negative 243 over, we have a to the 5y and b to the 20th. Because again, 4 times 5 is 20, y times 5 is 5y. So we get to the same answer as we had before, we just simplified first. And again, you can pick either method to achieve this.